There was a lot of stuff about flow nodes in Anders' PR, and so I realized I kind of needed to learn what flow nodes were. And there is very little documentation about them, but I played around and I wound up adding this nice little visualization to the TypeScript AST Viewer. So it's a little more clear looking at this now that flow nodes are a graph, and they kind of trace back execution through the function that you're looking at.
Welcome, everybody. We have Dan Vanderkam and Josh Goldberg here. We're going to be talking about a very famous and popular PR that Dan put into the TypeScript repo. It's got a lot of fanfare behind it, and people are very excited. I found out about it because somebody in the Michigan TypeScript Discord had a watch on this PR, or on the issue that this PR closed for like years. And we were all very excited when we saw the notification come in that it was closed. So Dan, tell us the story about like how this all happened and how it came to be that you put this PR in.
Yeah. So I'm like very excited about this PR as well, and I've been very happy to see all the positive reception it's gotten. So I guess the backstory here is that I've like used TypeScript for a very long time. Probably, I think I started using it in maybe early 2016, and I've written a ton of it over the years. I've written a ton about it. So I have effectivetypescript.com, the blog, and I wrote Effective TypeScript, the book with O'Reilly. So I've definitely been in the TypeScript ecosystem, but I'd never contributed to TypeScript before, and that always felt like I don't know, just like a stone unturned, right? Like I thought, maybe I would learn some interesting things about TypeScript by doing that. And at the start of this year, opportunity came up for me to do that. So I've been participating in this program called the Recurse Center, which is sometimes billed as like a writer's retreat for programmers. So I applied there and said that you apply with a project, and my project that I had in mind was I wanted to contribute to TypeScript. So that's sort of how this all came about. So I looked at what's like a good first issue to get going on.
Wait a second. That was so cool. You can do @me at the end of the URL. Sorry.
Oh,
completely unrelated. And it shows you your own PRs.
Oh. Yep.
Okay. Go on.
Learn something every day.
Yeah, I guess.
So yeah, I wanted to, I had like a laundry list of, features I wish TypeScript had. I'm sure a lot of people have a list like that. But I figured it was better to start with something just like really trivial to, make it easier on me, and also increase the odds that I actually like got something merged within the 12-week program. So yeah, finding a PR or finding an issue that was simple but not already fixed by someone actually proved to be like kind of hard. They have a like good first issue label. Let's see if. Yeah, good first issue. I found that a lot of these were not good first issues, which we don't need to dig too far into those. But all right. It took me a while to find an actual good first issue. But I ran across this, which was, filed by Tom, who I haven't met him personally, I don't think, but I'm a fan. He created geojson.io, if people are familiar with that, and a bunch of other JavaScript tools.
All right.
But the gist is that when you write a number with a numeric separator in it, so that's this underscore, that wasn't getting preserved when you targeted ES 2021, which
makes sense. So, which is where the feature was introduced.
Yeah. So, I guess I fixed the bug now, so it's harder to see. But ES 2017, it removes the underscore on the side. Yeah, I see
on the right. Okay.
Yep. Yeah. So yeah, this is good. Good for people to remember that, what your TypeScript is not the thing that's running. It's this generated JavaScript. There's always generated JavaScript. So yeah, if you increase the target ES version, that feature was added in 2021. And so now, thanks to my PR, like the underscore is preserved, which, you know, this fix was like as trivial as you might expect. It was, yeah, there was an equals ES next, and I changed it to a greater than or equal to. But I think the reason that bug existed was because when they added support for numeric literals or numeric separators, that it hadn't been standardized yet. And so they didn't have a target to set it to. So they just set it to ES next and never changed
Not necessarily a bug in that sense then, just things changed.
Yeah. Yeah. Time progressed. So that convinced me that, this was like feasible. And, I think like time from starting working on this to like actually merging it was maybe like 3 or 4 weeks, which seemed like not terrible. So that was encouraging.
Sorry, what was that? Sorry, before you continue, I just, while we're still talking about the merging, what was that comment from
I saw that too.
From Ryan?
He said not a bug. Wait. Sowing the grounds for the first Y2.1K bug.
Okay. Yeah. So this is a general problem, right? So Ryan's proposal was that we add an explicit ES 2099 as like a internal only thing, like a placeholder for, this should be something else. We just don't know what it is yet. And, then I was joking that I was excited to see the feature set of ES 2099 and we realized that would become a bug in, 80 years.
I do find it both charming and kind of encouraging that I see, or like we see right now, some of the same behavior dynamics that very, very many dev teams have of, hey, should we do this? It might be a good idea. Let me ask around. Like that's the type of thing you expect, like, oh, should we prioritize this bug in the backlog kind of conversation? And this is 3 or 4 of the very senior members of the TypeScript team having the same kind of casual chat about TypeScript and the JavaScript standards. It's kind of cute.
Yeah.
Yeah.
Yeah. So, so that was encouraging. So then I sort of set out to, for my next one, I wanted to work on something a little meatier. So let's see. Yeah, so I looked at issues I'd filed in the past, and this one really stood out, right? So I filed this issue in...
Is that 545?
Upvotes, yeah.
Upvotes, wow.
So I filed this issue in 2017, and I kind of forgot about it until one day I did a sort of the open TypeScript issues by like number of upvotes, and this one was I was quite surprised to see my name in the top like 10 or 20. So it seemed like this was I was not the only one who wanted this. So yeah, I guess I can kind of explain the issue here because this will motivate the pull request. So if you have a list, or actually let's start with something even simpler. So like, let's say you have a number. So, it could be either, 10 or null. So the TypeScript's going to infer that the type is number or null. So then if we do an if statement, TypeScript will narrow the type inside the if statement so that it's just number, right? So this is control flow analysis. This is narrowing. This is like one of the patterns that we all kind of learn about TypeScript and like learn to embrace. So that works great. The problem is, what if you try to extend this to arrays? So, let's say we have 1, 2, 3, 4, 3, null, 5. So now TypeScript infers the type of this as an array of number or null. So each element could be number or it could be null. So then we could filter out the nulls, right? So now nums is an array that does not, it removes this null value and keeps the numbers. So you would hope that the type of this would just be number array, but it's not, at least as of TypeScript 5.4. So the problem is that TypeScript just can't follow along with this logic. And traditionally the way to fix this was to introduce like a is non-null function. So, in
like
this case, we can make it take, yes, exactly. So you can swap this in, like this is this doesn't fix the issue at all. But what you can do is, and I'm gonna make this a little smaller. So you can, any function that returns a Boolean, you can change it to be a type guard. So this returns x as number. So what this is saying is that when this function returns true, TypeScript can know that its parameter is, that its argument is a number rather than number or null. And the built-in array methods like filter they have overloads for type predicates. And so the net result of this is that this comes out as an array of numbers.
I didn't know you can write overloads targeting the situation where a predicate is passed. I guess it's probably off topic, but now I'm curious about how that works.
Yeah. I mean, you can see it right here. So predicate value is number. So yeah, it's
wow,
just like
you can put, I've never seen that. Okay, so you can put the is, would it be an operator? You can put that is thing in there in a type definition. Wow. Okay, cool.
Yeah. In like TypeScript showing how it's showing the instantiated type parameters here, but like in the actual like lib.es5.d.ts, this is all generic, right? It's it's array of t and value is s. But yeah, it works pretty well. And in fact, that was sort of the conclusion on this issue, is that like you should just use a type predicate. That's kind of where things stood for quite a while. But it was always kind of unsatisfying to me because there's nothing actually like wrong with this code, right? There's no reason that TypeScript couldn't infer from this code here that this arrow function is a type guard, like is a type predicate. And so that's what this issue is all about, was inferring a type guard. So I thought that might be an interesting PR to dig into. So that's basically what I did. So I guess I can talk about how I like initially thought this was going to work, and then that can maybe transition into how it actually did work.
Let's dive in. Yeah, I'm very curious about how to approach such a thing. Like I've debugged things through the TypeScript codebase and changed a few little parameters here and there, but I'm very afraid most of the time to do anything in the TypeScript codebase because it seems like way over my pay grade. So how do you even where do you start in something like this?
Yeah, so I had this, the thing that I was initially thinking when I started working on this PR was that Anders introduced this new feature in TypeScript 4.4, which I think came out in 2021, that let you, they created these aliased conditions. So the idea here was, let's say we have a function that takes number or null. I'm gonna hide the JavaScript, but we'll just remember that it's there. So yeah, if like we were seeing earlier, if you do a conditional, then inside that conditional, X potentially has a different type, right? It has a narrower type. And what Anders did in this PR was he made it possible to pull that condition out into a variable. Inside this if statement, X has a number type, which is interesting because at least in my mind, that meant that somehow like on this OK variable, there was some sort of information that TypeScript was attaching to it that said this variable narrows the type of X.
Mm-hmm.
And so I thought that, the difference between
Yeah, we're getting pretty close now.
Yeah, that felt, so this was the function I wanted to target, but that felt kind of close to this, right? Which would trigger Anders alias conditions. So yeah, I thought maybe my story around like why this issue had never been fixed was that maybe it was impossible in 2017, but now thanks to this like change that Anders made in 2021, maybe we have the mechanisms we need to implement it. So that turned out to be like completely wrong, but it did at least like get me interested in this issue and got me like digging. So I guess my clue that something was wrong, or my clue that things were not the way they were that I expected them to be, was actually looking at Anders' PR. So in my mind, I assumed that there would be some like information stored on that OK variable, and I just needed to find that information. And looking at Anders' PR, there was actually no information being stored anywhere,
Wow.
which really like did not jibe at all with my understanding of how like type inference worked, right? Because I, in my mind, like this would only make sense that this would get the right type if there was something being stored on this OK variable.
Does foo in this case return number? Is the type inferred type of foo number return type? Like if you hover over foo?
I think it's Boolean, right?
Boolean.
At least as of TypeScript 5.4. Because OK is whether X is not equal to null.
Right, we're returning right? OK, not X. All right, got it.
Yeah. Yep. If we returned X here and then, we threw an error here, then in that case, it would return a number.
Okay.
Right?
It's so close.
Yeah. So, I guess, what this wound up being like kind of the big learning, thing for me here. I realized there was a lot of stuff about flow nodes in Anders' PR, and so I realized I kind of needed to learn what flow nodes were, and there is very little documentation about them, but I played around and I wound up adding this nice little visualization to the TypeScript AST Viewer, so it's a little more clear looking at this now that flow nodes are a graph, and they kind of trace back execution through the function that you're looking at.
Oh.
So I actually have a blog post about this. Take a look at this if you're interested in kind of the details on this. But the idea is that
you added just to make sure I got this. You added this visualization thing to the TypeScript AST Viewer.
Yeah, I found it like completely impossible to understand what was going on with flow nodes without something like this. Like
awesome.
I'm a pretty visual person, and so once I realized it was a graph, I was like, okay, I need to visualize this graph. And yeah, it's kind of fun. The idea, I think the intuition is that each statement has a flow node, and the flow node is the previous statement that could have executed. So, yes. So if we have like a branching construct, then the previous statement that could have executed before this return OK, well, it could have been either of these branches, right? And so when TypeScript is doing control flow analysis to figure out the type of a symbol, what it does is it traces back up through this flow graph, and it sees, okay, I'm in a true condition, and then it maybe it's easier to see if you do this, but it sees it's in this true condition, and the condition is x is not equal to null, and so it uses that to refine the type. And if you have multiple refinements, I don't know.
Oh, I see.
Here. Right. So inside here, x is string or number. Inside here, it's we can't really see it, but
it's this one big thing, yeah.
It's number. So yeah, so it's able to there's and it turns out inside checker.ts there's just this whole giant list of functions that match each of these different types of conditions. So here's some of them, narrow type by truthiness, narrow type by binary expression, narrow type by type of.
Oh.
So that's just all of the different ways you can refine a type. So, but yeah, that was this was actually so the TS AST Viewer, this is Dave Sherritt's project. I think he's with Dino, and yeah, he was very receptive to merging this visualization in. And yeah, so even before I merged the PR, this was kind of a nice tangible byproduct of creating a new visualization for the ecosystem. I tweeted about it, and it seemed like I was not the only one who was confused by flow nodes. Anders was quite excited to see that visualization. Yeah, so then I guess that was a lot of backstory, but how it was sort of unclear to me for a bit how whether that made it easier to infer a type guard or not. And so eventually what I decided was that I could still infer a type guard in this system. The trick was just that whenever you had a return statement like this, I needed to kind of secretly rewrite it this way and inspect what the type of X was inside this branch. Mm-hmm. So that was kind of the intuition for how my PR works is
oh wow, really?
I synthesize a new flow node, so it's a flow condition, and I check out what the type of X is in here, and if it's something other than the declared type, then we have a candidate for a type predicate. So this was kind of the function that I added, get type predicate from body. So there's some ceremony around what types of functions do I want to run on? Probably not getters or setters or constructors. And I just restricted myself to functions that only have a single return statement. It's possible to make it work for functions with multiple return statements, but it's harder, and that doesn't really seem like the common case. It can't have an implicit return. And then it needs to. This was kind of a fun realization. If the identity function for Booleans, in theory, this could be a type predicate, right? Right, and so that was actually a lot of the diffs that wound up showing in the TypeScript compiler baselines when I first implemented this. So I decided it would be simpler to just exclude that case because it doesn't really seem that useful. oh yeah, if you reassign the parameter in the function, then we probably shouldn't infer a type parameter for that. So yeah, then this is kind of this is the important bit. So we create a true condition, and this antecedent is how we plug it back into the existing control flow graph at the return statement, and yeah, then we call get flow type of reference, which is how TypeScript figures out the type of a symbol at a location, and we check if it's the same as the initial type, and if it's not, then we have a candidate for inference.
Okay.
So that's sort of the gist of it. And yeah, it's kind of that is still like to a large extent how it works. There's and like intuitively that is that's just exactly what we saw, like where you have this return statement. I just rewrite it as this if statement and check out the type of X in this location. So the problem is their type predicates actually have some kind of precise semantics around like not only what does it mean when they return true, but also what does it mean when they return false. So as I was working on this, I have a Notion doc of like all my notes on this PR. I think it wound up being something like 70 pages long. Like there were just there's just a lot. So I as I was going, I would just write down like what are questions I have, like what are things that confuse me, and then over time I would try to answer those, and I would also try to collect like pathological cases that I could think of that I should maybe test for. So the one that really like made me think about this false case is this one, right? Random is greater than 0.5. Or yeah, I can do just like ampersand. So this, like, should this function be a type predicate? It's like, well, if we apply the test,
sometimes it is.
Yeah. So if if this expression is true, then X is definitely a number, right? But if it's false, then X might be a number or it might not be a number, right? So, so TypeScript is smart enough to know that, right? So the type here is number or null. Whereas if we get rid of the random,
it'll just be null.
Yeah. So, and this isn't just this is actually like an important distinction, because if we so let's say that we made this type predicate, then remember we have X up here as number or null. So if we use this in an if statement, then TypeScript is going to assume that it's number here, but in this else branch, it's going to assume it's null, right? And this is wrong. It could still be number in this case. So type predicates have they have these like if and only if semantics to them.
Yeah.
Right. So when you write X as number, it means that if flaky as number returns true, then X is a number. But it also means that if it returns false, then it's not a number.
Yeah.
And that was actually something I did not know before I started implementing this.
I wouldn't have known it, except I had a colleague that used to rage about this element of type predicates, that in his view, this was a way that you can lie to the type system. And he viewed that as a soundness hole. Because you just did. You literally lied. You told it that the predicate does something it doesn't actually do. Because of you can do this in error too, because of perhaps a misunderstanding of the code.
Yeah. So I always tell people that, like type predicates are no safer than type assertions,
Yeah.
right? So
They're casts.
X is number or X at, I mean, you can't use it here, but like it's not actually that different than writing X as number. So it's it's funny that your coworker singled out this as the most notable example of unsoundness in TypeScript.
Well, one, I think it's good. It's good for the soul to work with people who think, different things. And I always appreciated that person's input. But yeah, it's true. It is a hole you can poke.
Yep. So yeah, I have a blog post out about this as well. So this was another thing that came out. Yeah. So
actually, I have to stop you there. So for those watching, thank you for watching this far in the video. We've been also thinking, and it's come up a couple times. There are lots of great authors of blog posts out there, and what people do is they'll do like reaction videos of like reading through a blog post. But that wouldn't be very Michigan TypeScript because we don't just do one-person videos. I've been thinking it might be nice to have videos where we read through your blog post. So Josh has a lot of blog posts as well, and of course Dan, we've seen 2 now that are really cool. If that's something interesting to you, please comment below. Or is it engagement baiting? You can come on the Discord or like email us or something. I guess I'll put the email on the screen. Just let us know if you think that would be interesting to you. And we can do those kind of videos reading through the blog posts. And I think it'd be a fun way to kind of open that blog to more people.
Yeah. So yeah, it seemed like from the Twitter reaction to this, I was definitely not the only person who this was not totally clear to. So but that's it's important to think about what it means if type predicate returns false. So that made me think that like I needed to refine my condition a bit. So I needed to look at the type of X not only in the true case but also in the false case. So and yeah, there needs to be some relationship between these. So in this case, we can say like the init type is number or null, right? That's the one that's declared. And the true type is what we have here. So that's number. And the false type is number or null. And the criteria I initially came up with was that I thought that you needed to have that the false type was equal to basically the initial type minus the true type. So exclude.
Yep.
So in this case, that's not true because number or null, exclude number, you get null here, and false type is not null. Whereas here, you do. Right, so here, false type is just null, and so then like t equals exclude number. Right, so this should just be null. Yep. So that was the criteria I had when I first put up the PR, and. Yeah, it was interesting to at this point I could start running all of the checks that the TypeScript, all of the tests that the TypeScript compiler has. So I also started creating some of my own, right? So yeah, I think I wound up with like a few hundred lines of tests that I added. I guess part of contributing to the TypeScript compiler is these baselines, they're called. So enter type predicate. So there's thousands and thousands of these. So TypeScript, when like its version of testing is they run the type checker over these TypeScript files, and they produce a couple of different output files. So this .types one is for each of the lines of code in this test file, it has it reports like what the inferred type of each symbol is, and then there's other There's others as well.
And this one is not handwritten, I'm assuming, right? It just generates it and then checks it into the code base. Yeah.
This one is generated. So you run, I think it's like hereby run tests or a run test parallel, and it like updates all of these. So there's thousands and thousands of them, and it gives you a sense of like whether there's unintended side effects or like surprising side effects of your PR. And so it was interesting for me to run my code against all of the TypeScript baselines, because that was how I learned about the Boolean identity issue. And it was also how I learned about some surprising like positive side effects, which is that when I started inferring type guards, when I inferred type predicates, that meant that type predicates could now flow between functions. Mm-hmm. So I guess I can show a quick example of that.
Before you do that, could I ask you a quick question about what you had just a second ago? So I'm not sure I can formulate this, but one of my instincts when you showed the if statement in the playground was the if condition will return, will take the false branch for things other than false. Like it'll take it for 0, it'll take it for nan, it'll take it for empty string. And I'm just curious if that fact kind of muddied the waters at all. It's not just null or undefined and false, that it will go to the false branch of the if for. Yeah,
that is an excellent question. This was also, I forgot to mention this. This was also kind of a realization, a funny realization when I realized that the false case, the else branch, was important. So the motivating example I have in this issue from 2017, it uses I can zoom in a little bit here. It uses a truthiness check, right? This bang bang, and. For exactly the reasons you mentioned, that should not be a type predicate. Right. So if it's truthy, then it's definitely a number. But if it's falsy, then
it could still be a number. It could be 0.
Could still be a number, right? Yeah. Because it could be 0. So actually, like, we should not infer a type predicate for a truthiness check. The distinction, though, is if this is an object type, like a date, then in that case, this is okay, right? Because here it's a date and here it's null. There's no falsy dates. There's a distinction between, especially for primitive types like numbers and strings, there's a important distinction between truthiness and like nullishness. We can look at this in a minute when we play around with my PR, but my change does kind of force you to be aware of that, which I think is a good thing.
You tell me if this is the right time to ask my next question. I also wanted to ask, people commented on YouTube and on Twitter when we posted about this PR about array filter with Boolean, like capital B Boolean. So whenever you think is the best time, I'd like to hear about your thoughts on that, because it isn't quite wrong that it works now. I think. But,
So actually, I think we should get to that in just a minute. But
great.
I do want to be clear. My filter Boolean does not work after my change. You still need something like TS reset to make that work. But I actually think you should not use filter Boolean. I think that's my hot take.
That's your hot take.
Okay. So because of this change, type guards now flow between functions. So this was always like an issue that existed in the past. So let's say x does not equal null, and let's make this a type guard. is num2. So this function is a type guard. This could be a type guard, but it's not. It just returns Boolean. So there was even like a independent issue about this, and I realized that because my PR started inferring type guards, it just applied all the normal rules of control flow analysis, and TypeScript was able to figure out that this function is also a type guard. Because you can do the same thing around like writing, an if statement, right? And it just like kind of trivially works, right? So that was sort of an emergent property of my change, which was really encouraging. I remember Anders has said that like you never want to just fix like one issue at a time when you're working on a programming language or a compiler. Like you always want to kind of fix like a category of issues. And so at least for me, that was a really exciting moment to realize that I was fixing problems that I had not even considered before working on this, right? That this had kind of emergent like positive effects. So I had a chat with Josh about my PR around this time, and I actually here's the PR. Yeah, I showed my PR to Josh, and he gave me sort of a pep talk, encouraging me to put it up for review. So thanks for that, Josh.
If I remember right, the pep talk was, "Please, dear God, please," something around those lines.
So so I put it up, and I wrote a pretty lengthy explanation of how it worked, and like some of the things that I win. So type guards now flow. That was a nice win. This was the thing that you were talking about, Dimitri, with truthiness. So we'll come back to that.
Cool.
And it got a lot of positive response. But an interesting thing was that the tests failed, and they failed for a really interesting reason, which I actually, so I'll look into the self-check errors. So self-check is...
because things are fixed.
Well, yeah, so here was an example of type guards flowing. So I updated the baselines for those, but the self check is so TypeScript is TypeScript is written in TypeScript, which is like kind of head scratching when you first hear that idea, but it's actually pretty common for programming languages. So it's called
Go is written in Go, Rust is written in Rust. Yeah,
exactly. Yeah. So the way I think about it is that TypeScript, 0.0 was JavaScript, and, TypeScript 0.1 was written in JavaScript, but then TypeScript 0.2 was written in TypeScript 0.1 and so on. So TypeScript 5.4 is written using TypeScript 5.3, and it kind of works out that way. But that means that TypeScript needs to, whenever you change TypeScript, it's important that TypeScript still be able to compile TypeScript. And so that's what the self-check was. So I had not run that test before, and that failed. And so
I see.
This is actually quite interesting.
Okay.
So right. This was actually kind of the maybe most scary moment of the whole process was this seemed to actually be kind of a deep issue with this approach. So let's take a look at my example here. So so we have this is short string function. So if we if we make this take string or number, and we do the same sort of checks, then you get back string or number here, and you get back string here, which implies that it should not be a type predicate, right?
Okay.
So, and that makes sense. Like, this probably should not be a type predicate. But if you change this to unknown, then in here, type is string, and in here, type is unknown.
Oh.
And, guess what? Exclude unknown. Well, I don't need to do this in comments. I can just straight code. Exclude unknown string is, in fact, unknown. So, so that relationship that we were looking for earlier still holds, right?
Mm-hmm.
And so yeah, like, should this be a type predicate? My initial version of the PR said it should, but it turns out to be a problem because if you make this like string or number, then here it's string and here it will be number, and that's wrong, right? Because this is sort of similar to the it's sort of the same as the flaky is number check, and it's fine to call functions with subtypes of their declared parameters, right? And so I realized that like my criteria I'd been using wasn't quite correct, and this was a scary moment because I was like, well, crap, like I've already put this out in the world and people are excited about it, and like maybe it just doesn't work. So I stepped away from the problem and went for a walk and came back with a solution, which was basically the criteria wasn't quite. I needed to make it a little more complicated. So the idea is that let me think about the best way to explain this. So it needs to.
Can you show the code? Is there like a place in the code that handles the added complexity, or like a commit?
Yeah, I can show you the code. I just want to like motivate it first, because
sure.
I think if you don't have the intuition, the code is not very doesn't mean that isn't going to be very meaningful.
Okay.
So basically the intuition was that like this was the right check. It's just that instead of only holding for the declared type, it needed to hold for the declared type and all subtypes of the declared type, because you can call the function with any subtype of unknown, and TypeScript allows that, as it should. Mm-hmm. So then I was like, well, how on earth do I check that this holds for all subtypes? Because there's an infinite number of possible subtypes. But then I realized that I guess kind of the only interesting subtype is the thing that you infer as the type predicate. So the check eventually became let me sort of show you how this works. So you start with you start by looking at the true case. So the true case here is string, right? So then what we're going to do, true type equals string. So we're going to take this true type. So that's the candidate for the type predicate string. Yep. We're going to go back here and plug in string.
Oh.
And now in the false case, we have to have, we need to have never left. Mm. So we can call this like the false subtype. So the intuition here is that this is kind of like a direct encoding of the if and only if. So in this case, the true type is string and the false type reduces to never, right? So that's kind of saying that if it's basically directly testing the semantics of type predicates. So if you feed back in the I don't know, the predicated type, right, the true type.
Yep, the original one.
In the false branch, like there just can't be anything left, right? Like it needs to for it to be a valid type predicate. Everything needs to be excluded by the time you get to the false.
This is so cool. I have to say, I'm very surprised by this is the second time in this call we've seen like taking the pieces that TypeScript already has and like rewriting some code synthetically in memory and seeing what the inferred types are and then like using those values critically or concretely. So that's really cool. Is this something that you've seen, or is this something that happens elsewhere in the TypeScript code base, or is this something that you kind of came to be using intuitively?
I'm not aware of anywhere else in the code base that they synthesize flow nodes in the type checker.
I love it. So clever.
Which might, I guess maybe there's a broader question of like why hadn't anyone done this before? And maybe one theory is that like no, I just didn't know that wasn't a thing that people did, right? So that wound up being the final criterion, and the other like kind of beautiful thing about this is that checking if a type is never is actually much simpler than calculating this exclude and like doing a equality check between types. So it actually winds up being more efficient as well. If we jump over into the code, that's basically how it works. Check if this is kind of the workhorse. So we get the true type. If it's the same as the initial type, then it's not a type predicate. Otherwise, we check the false condition, and we feed in the true type here and just check whether it's never. And that's kind of how it works.
Wow. I don't know why I was so scared to see this code, because I thought it would be very complicated, but it's not. You got all the helper types.
Yeah, I think I was quite happy with how simple this wound up being. It took a while to get here, but like the actual meat of the code is really like just this, which is only a few lines of code. And I think the nice thing about it is, like you said, it's a creative use of existing control flow constructs. So it doesn't really add anything new to it doesn't add any new concepts really. It just reuses all the existing machinery.
Yeah.
So
makes it easier to review as well from the team side, I'm sure.
Yeah, totally. I got, oh, wow, there's a lot of
155 hidden items.
People wonder why programming languages evolve slowly. It's because every single change, even something as so mind-numbingly obviously good like this one, has an incredible amount of potential side effects that need to be discussed.
Yeah. So I'm trying to find, Anders did a code review for me. This like made my year. Anders reviewed my code and said he really liked the core idea and thought it was clever.
Wow.
So that's going right on the resume.
Yeah, time to put that on a t-shirt.
That is the resume.
That's awesome.
You don't need anything else.
So then it got discussed in the weekly design TypeScript design meeting. Yeah, design meeting notes. Basically the gist of this was that they liked it, and they were a little concerned about the performance hit, right? So there was consistently like a 1% to 2% slowdown on some of their benchmarks, And so, once the core behavior was in place, there was a lot of work on just like trying to figure out why is it slow, and can we make it any faster? And basically like all of the slowdown turns out to be applying this test to see should this be a type predicate, and in particular it winds up being a few kind of like pathological cases. So this in one of their benchmarks, like this, just determining whether this has bindable name function should be a type predicate, winds up accounting for something like 80% of the total slowdown, because declaration is I think it's a union of something like 300 different types. And so applying the checks of the type on each side of the if statement winds up just being like very complicated, because it has to check it against all of the 106 more. Okay, so maybe not 300, but it's a lot.
It's a lot.
Yeah. So that wound up being, well, a lot of people spent a lot of time digging into that, and ultimately, like, I came up with a few optimizations, but they did not seem to actually make that much of a difference, unfortunately. Yeah, it was a good theory. So I think if there are performance issues with this, there are a few things that we could do, but ultimately, TypeScript team decided that they were comfortable with this for the wins.
It's a pretty big quality of life increase for lots of people.
Yeah. So I guess, with that, maybe we should just play around with this. So, so this is live on the nightly. So if we update to that, then we should see some new behavior. So in particular, so if you remember, nums came out as an array of number or null before. So now it's just an array of number. Woo-hoo! And that works because TypeScript infers that this arrow function is a type guard, is a type predicate, and it matches this value as number case. But Dimitri, you were asking about truthiness checks before. So if I do a truthiness check here, this does not work, right? Because
as it should. Yeah. Because 0 is a number still, and 0 is false.
So I guess it's like a little unsatisfying in this case, because TypeScript could still, in theory, infer that this is an array of numbers, because filter only cares about the true side of the type predicate. But there's no notion of like a one-sided type predicate in TypeScript, and so like there's no way to make this work without adding that.
We actually have previously talked about this, you and I believe in person many years ago. There's an issue I filed on TypeScript 45329 in 2021 asking that string union types should be narrowed it should be able, when narrowed to falsey, to just the empty string, which you thumbs up.
Oh yeah.
Yeah. So if anyone's interested,
me and one other person.
Yeah.
I think it seems like the conclusion was that this was, correct, but maybe not
super usable.
Not worth it.
I wonder if with your pull request going in now, this becomes more valuable for the cases we're discussing about falsiness.
Yeah, I guess the gist is that TypeScript needs some way to represent like numbers that are not 0. But I think the current this current behavior is kind of a good thing in some ways, because you actually you almost never want to filter out null and 0 from a list. You almost always want to just filter out the nulls. So like the example I like to use is if you have like a collection of like test scores from different students, and like maybe one student didn't take the test, so you want to filter out that as a null value. But like if a student got a 0 on the test, then if you're calculating the class average, you do need to include that 0, right? And so this is kind of I think it's actually like maybe a good thing that we push you towards doing a check against null, or this if you use a single equal, this checks null or undefined, is another shortcut you can use. The behavior is actually a little more subtle though. So you remember earlier we were saying that if you do a truthiness check, then it is okay to be a type guard for object types. And so actually this does work. So here, yeah, exactly. So this is, date or null or undefined array, and this is just date array. Whereas, in this case, it's if I do bang bang x, since it's a primitive type, it doesn't apply the filter in that case. And yeah, it's kind of nice that this is just like a property that naturally emerges from the type predicate inference, because that's the behavior of if statements in TypeScript.
Wow.
I guess that's my little spiel about like why you shouldn't do filter Boolean. Filter Boolean is equivalent to this, because if you're using it for primitive types, then you have this sort of footgun around like truthiness versus nullishness, and
yep.
Also like I just point out that x arrow bang bang x is well, okay, if you put a space in it, it's like one character longer than Boolean, fine. But
God forbid. I do think I agree with all the points you're making on how to write good TypeScript code, or like the common cases for good TypeScript code. However, I think one thing that gets underestimated a lot in discussions is the value of the term is pedagogy, or teaching. When you and I write TypeScript books, we need very small, succinct examples, like little pre-canned ones, to explain these things to people, as does anyone doing a TypeScript workshop or blog or whatnot. So you end up with this disproportional desire for really small snippets that don't really make sense in real life. And I think being more precise in those snippets actually would be really useful. So I still am in favor of, getting more precise and technically accurate here, even though real world TypeScript developers day to day probably wouldn't really benefit from it and might even need or want to be pushed away from it.
Mm-hmm.
Yeah, I think there's filter Boolean is like kind of an interesting question. So like TS reset is pretty popular, and it includes special overloads for filter Boolean. So I actually like did a fairly deep dive on this recently. So the thought was that you could either you could modify the declarations of array.prototype.filter in the TypeScript lib file to special case Boolean constructor.
Yeah.
Or the important thing is to only do it for arrays of object types, right? So lowercase o object is that excludes things like string and number that have the falsey values. Or another approach would be to just make Boolean itself a type predicate, and they so these both turn out to not work for kind of interesting reasons. The issue with adding this filter, this new overload for filter, is that TypeScript has a special case for arrays that are unions of two arrays. So this is fizz array or buzz array, as opposed to like if you can visualize the parentheses, fizz or buzz array. And the logic is that if you try to call a method on a union of arrays and it doesn't work, then it falls back to calling it on the array of the union, which does work in this case. But once you add this new overload, then this is actually like TypeScript sees this as a possible overload or as a possible method to call on this union of arrays, and you get this like weird error message about Boolean constructor. So that, I think that's actually kind of a fundamental issue. You have that problem if you use TS reset as well. And then the issue with Boolean constructor, I think, was a little that I think that could be made to work. But there's sort of a more subtle issue that Anders explained it in this Twitter thread. But I think the gist is that TypeScript takes some shortcuts for performance reasons, and it winds up not being able to see the correct overload.
Yeah.
So,
this is so exciting. It's a wonderful time to be alive, to be writing TypeScript. I think so many people had lost faith that this could ever or would ever be fixed, and you came along here in pretty quick time as well and took care of it. I don't know. Just thank you for putting this all together. And you have really improved the quality of code bases around the world with this change. And it's so great to get an inside view into how you thought about it. And I don't know. This has just been amazing. Do you have plans after this? Like you just showed us one, but do you think there's, did it give you the will to go on and do more longstanding TypeScript issues? Maybe you can implement negated types or something next.
It's a little scary to feel like some of these issues are like possible now, because now I feel like, if I want this feature in TypeScript, maybe I should try to implement it. So that's I think I don't know that I'll invest like quite as much time into other features as I did into this. I think if the goal for me personally was to like learn more about how TypeScript works, I think I've definitely succeeded in doing that. So maybe there's diminishing returns on doing more like big PRs like this in the future. But I guess I think of it as I was kind of imagining it as like you're playing Jenga or something, right? And you just like poke at little blocks and see which ones are gonna like give way more easily than you expect. And
it's good to know someone as talented at this kind of stuff as you feels that way, because I always feel that way. So maybe I'm in the right direction. You too, Josh.
Yeah, block the rim. Yeah.
But
cool.
I think it is pretty exciting to. I think this change turned out like better than I had any right to expect it to. I think some interesting realizations along the way were that like this actually could have been done. I thought this had something to do with the aliased conditions that Anders introduced in TypeScript 4.4, but it actually turned out to have nothing to do with that. They do make it like somewhat nicer. Like if you do this, then this will be inferred as a type predicate, right? This is the X's number here. Mm-hmm. But like that was not actually, that didn't actually turn out to be relevant to the PR. Like anyone could have done this at any point, basically, since the never type was introduced in maybe like TypeScript 3.
I do think you had a pretty clever, you came up with a pretty clever solution, as Anders himself said. So give yourself some credit, because this is amazing stuff, and I'm so impressed by what you showed us. It's an amazing piece of work.
Yeah, I'm very happy with how it turned out, and I think it is kind of fun to think that like this, back in January, this was like a little experimental branch on my laptop, and within a month or so, it's going to be running on like literally every TypeScript function in the world. So that's
hell yeah,
it's kind of exciting to think about.
Well, yeah. Thanks again, guys, for joining this call. I hope to do more stuff like this in the future. Please, below everyone watching and listening, thank you for watching. Leave your feedback. and let us know what you think of doing little videos on PRs like this. Cool. Anything else? We all good?
I think we're good. Turned out to be not less little than expected. I guess.
Yeah.
Sorry we went a bit over,
Yeah,
but
that's okay. Cool. I'll see you guys later.
All right, sounds good. Oops, sorry. So the